In this module, our goal is to discuss correlation and regression analysis. Correlation and regression analysis is all about looking at the relationship between two variables, especially when we talk about simple linear correlation analysis, which will be our focus for this topic. So if I gave you data on how much you've spent all year long on gas, and I also give you data on how many miles you've driven all year long from one place to the other. So let's say that this data was collected on a monthly basis. So for the month of January, you have how many miles you drive with your car and how much you spent on gas. What do you think? Is there a relationship? I would dare to say that there is one. Well, it is one thing to make a claim that there is a relationship. It is quite another to use data you have collected to back your claim. That is what this topic is all about. Using data to establish a scientific, clear-cut evidence for any relationship that we agree or observe or suspect might exist between two numerical variables. So without any further ado, what is the first step in trying to analyze or describe the relationship between two numeric variables? We begin by looking at scatter plots. What is a scatter plot? A scatter plot is a picture that shows us the relationship between one variable and yet another variable x. So in this context, let's use an example to illustrate it. How exactly does Zillow figure out the worth of a house? Usually, most times when people want to buy a house, the first thing often mentioned in describing a house for sale is the size of the living area. So let's start with just one variable, like the size of the living area. And we hope or we anticipate that the house prices will depend on this particular variable. The big question is, how well can living area be used to predict home prices? The first step is to assign roles to the two variables. Remember, the two variables are home price and living area. So which one would depend on the other? I think reasonably, home prices will tend to depend on the size of the living area. So we tag home prices in this context, the dependent variable. And the other variable, which it depends on, we call it the independent or the predictor variable. In some other context, the dependent variable is also called the response variable. So as far as this scenario described in this example is concerned, home prices depends on the size of the living area. So home prices is assigned the role of the dependent variable and the placeholder for it is y. Whereas size of the living area that the home prices depends on would be your predictor or independent variable. Now, the next step then is having assigned roles to these variables, we would like to see what the connection is. And the first step is to look at a picture of if there is a relationship between these two variables. So to do that, we're going to use a random sample of 1728 homes from the public records of sales in upstate New York, in the region around the city of Saratoga Springs, in order to plot a graph of Y, that is, the home prices, versus X, the living area. So, if you look at this picture, I can see a general pattern here. And the general pattern I see here is a line, a linear line. Might this remind you of y equals mx plus b, something you might have learned in algebra back in high school? So immediately I see this trend. This begins to tell me that in living area or the size of the living area shows a little bit of information, a potential to offer information in predicting the prices of the home. In particular, we can say that in the scatter plot above, that there is an overall trend. Larger houses tend to cost more, and that is what you used to call positive slope. That is the meaning. Larger houses tending to cost more. We can see that there are some stragglers here, which tells us that this relationship is far from perfect. Let us see another instance here. And on page 3, we're told that the Texas Transportation Institute, founded in 1950, studies and develops solutions to challenges faced by all forms of transportation. Although the goal is to solve the transportation problems of the year 2025, the Texas Transportation Institute started collecting data on the relationship between freeway speed and the cost to society of freeway congestion as early as the year 2000. So, in this context, we are looking at two variables, freeway speed and how much it will cost an individual that he or she is stuck in traffic. So, we look at the question here. Which of the highlighted variables above should be assigned the role of the dependent variable y, and which should be assigned the role of the independent variable x? In other words, which variable should depend on the other? I would argue that being stuck in a car and how much it might cost you, that is, in terms of potential earnings, that would be congestion cost. This will depend on how fast the freeway is moving. If you're caught in traffic, you lose more. If you're not caught in traffic, you're able to get to work and start making your money. And so, to give a reasonable illustration of if this relationship exists, the data that's been collected since 2000 was plotted in a scatter plot. And so, of course, congestion cost, which depends on the freeway speed, is going to be on the y-axis. That is, since it's a dependent or response variable, and the freeway speed would be our x or independent variable. What do you think? Do you see a general pattern here? I do. I see a linear relationship here. So, and this linear relationship seems to be sloping downward from left to right. So this might remind you of negative slope when you have y equals mx plus b. What does negative slope really mean? So this might be telling us that as the freeway speed increases, we find that the congestion cost reduces, which will make intuitive sense. If you're able to move faster to get to where you're going or to get to your workplace, you don't lose hours in traffic, and that means you can make your money. So as freeway speed increases, the cost, the amount you're losing, cost or money you're losing tends to what? To reduce. So with that said, let us see if there are other forms of relationships that can be observed in a scatter plot or a scatter diagram. Just to remind you, or to formally state it, what is a scatter plot or a scatter diagram? It is a graph that shows the relationship between two quantitative or numeric variables, as you have seen in the previous examples. Here we had congestion cost measured in dollars per year. This is a numeric variable. And you have peak period freeway speed. That is also another numeric variable. To look at the relationship, we plotted a scatter plot or scatter diagram. And so, in general, a scatter plot or a scatter diagram is a graph that shows the relationship between two quantitative variables that are measured on the same entities. In earlier examples, I have shown you that you can have a positive linear relationship. We also saw the instance of a negative linear relationship. That brings to the fore the question, do we only observe linear forms of relationship? The answer to that question is no. For instance, in this picture or in this graph, we can see a curvilinear relationship. The same goes for this graph. And in this case, we see no clear-cut pattern. We see no relationship between y and x. So also do we have in the last picture here. With that said, let's move on to page 5. On page 5 of your notes, our interest is in making more sense of scatter plots. In other words, when you look at a scatter plot, what key characteristics should you look for when you want to describe the overall trend you see in a scatter plot? Here we go. You see, we go back to the example we had earlier, where we plotted home prices against the size of the living area measured in square footage. So we've said that we can see an overall general linear pattern here. And we can see that most of the points are clustered around that line that seems to capture the trend or relationship between price and living area. So, as a student of statistics, what particularly should you talk about or highlight whenever you look at this scatter plot? There are 4 key things to look for: the direction, the form, the strength, and whether you have outliers or you do not. So let's take them one after the other. As far as direction is concerned, you're interested in if you have a linear relationship, for example. Is it positive? So I can see a positive one here because if I raise my right hand up, this matches the general trend here. When I raise my right hand up, what you see is a trend going upward from left to right. So this is definitely a positive linear trend. Otherwise, as we saw earlier in the case of congestion cost versus peak period freeway, this is a negative linear relationship. And so, going back here, what we observe in this instance is that the overall trend is that as the living area goes up, so does the price also go up. Thus, the direction is positive. We note that there are some outliers, maybe potential outliers or influential values. So we can say that the relationship is definitely far from perfect because not all points lie on a single file or straight line. The next thing is to talk about the form of the relationship. The form of the relationship here is linear from left to right. And we also talk about the strength of the relationship. In order to observe the strength, we're looking for how close or how cluttered or how clustered around this line of best fit are all the points that are plotted on the graph. In this case, you might observe that some points are scattered away from the line. That are just those are just, for the most part, unusual cases. Our highs tend to wander to those unusual cases, but what we're interested in is where the majority of all of the points fall. So we can say in this context that since majority of the points fall reasonably close to the line, that there is a moderately strong association between living area and the prices of homes in this particular area. So in other words, information provided by living area is a very good predictor of home prices. And then finally, we talk about whether you have outliers. Well, I would guess that this guy and maybe this guy, this will be subjective, just to put that out there. This will be subjective. Some of these points appear to be unusual observations, which are standing away from the general pattern that we see that we see for most of the other points. And so the red circled points might be considered as outliers. So while subjective, each needs further scrutiny or examination. Let's look at another example. So again, on page 6 of your notes, we look back at the scatter plot on congestion cost per person measured in dollars per year versus the peak period freeway speed. Of course, we see a trend here, And as far as direction is concerned, we can say that it appears that as the peak period freeway goes up, the congestion cost or the cost of congestion goes down. That tells us that we do have a negative direction of a linear relationship here. Of course, what is the form? The form is definitely linear. And this means that there is a cloud or swarm of points stretched out in a generally consistent or straight form. Then we proceed to talk about the strength of the relationship. What do you think if you look at this? So if we assume that this red line right here captures most of the points, the general trend, do you think that most of these points are reasonably close to the line? Again, that is subjective. For me, I would say that based on strength, that the traffic congestion plot shows moderate scatter around a generally straight what? Linear form of relationship. And this indicates that there is a moderately strong linear relationship between cost and speed. Then what about outliers? Well, for me, I don't really see a particularly um, strong point that, or a particular point that is strongly or markedly or considerably standing far away from most of these points here. So I would argue, subjectively speaking, that there does not appear to be outliers in the overall trend of this scatter plot. So please do not forget the point that is very important to note. Whenever you observe a scatter plot, you want to talk about the direction, the form, the strength, and whether you have outliers or not. To deepen our understanding, let's go a little bit further to page 7. And on page 7, our goal is to look at scatter plot 1, 2, 3, and 4. What is our interest here? We would like to look at some of the scatter plots and the key characteristics they exhibit. And that will help us to answer the following questions. So let's see. Which of the scatter plots show little or no association? Well, I would argue that that is 4 because I don't see any clear visible pattern here. It's not linear, it's not curvilinear, it's not linear. So this definitely shows what? Little or no association. And that is because there is no clear-cut pattern to the scattering or clustering of points in the plot. So the next one is, which one shows a negative association? Well, that would be 3, the one sloping downward from left to right. That is because as x increases, y also decreases. So there is a general consistent trend in a linear form from left to right. Question C. Which one shows a linear association? I can see a linear association here. I can see a linear association here. So that will be scatter plots 2 and 3. Then which shows a non-linear association? The association exists, the connection exists, but it's just not a linear one. And that would be, my own judgment, scatter plot 1, which almost looks like a parabola. And so this is a non-linear parabolic model that would be best appropriate to model the relationship between y and x. Then which one shows a very strong linear association? I think that would be for the most part 3, because most of the points are clustered around that line of best fit. That would be my correct answer here. So as far as I'm concerned, the first 7 pages here that we've gone through has shown us how to look at scatter plots as the first step in a regression and correlation analysis. You look at the picture of the relationship between y and x, and you try to make out the clear-cut characteristics of the scatter plot. And remember to look out for the direction, the form, the strength of the scatter plot, as well as if there are any outliers. This is very important as the first step in regression analysis.